I hope everyone's doing well with the new year. This is our first Open Metadata community meeting of the year, so really great way for us to get the year started. Um, while we wait, as we while people are drinking, I'd like to welcome you to all enter what country you're from into chat. I know we have a very international community as for Open Metadata. We'd love to hear where you're from. I'm seeing a lot of representation from Brazil today, but also I'm seeing Belgium, Italy, Australia, UK, California. Uh, more people, more representation from Brazil, Hungary, Tunisia. Wow, that's rep United States, Malta. Quite the diverse crowd joining us from around the world. So thank you. Good morning, good afternoon, good evening, whatever country that you're joining us from for the start of the new year. So I guess the slide I put snow on the slide, but I guess depending on what hemisphere you're from, that might actually not be accurate. I might actually should be putting a maybe hot sun, depending where you're at. But at least where I'm at, it's a bit on the chilly side. All right. I think we've let's go ahead and I'll walk through our agenda for today. I think we've got a lot of really great content to get this year started. So, as always, as part of, if this is your first time joining one of our meetings, this is our monthly Open Metadata community meeting. It's a chance for us to come together as an open source project and check in on how we're doing as a project and as a community. We run through some updates and metrics. We'll go through, share stories from the community, and we'll also be hearing from the Carrefour Brazil team on how they're using open metadata as part of their data strategy. After that, we'll also be doing a feature deep dive. So one of the Open Metadata engineers, Mayor, will be coming on to tell us a bit more about Lineage, how it's built, how to use it, and a bit more on what's more to come. At the end of our presentation, we'll also have a Q&A. So lots of really great content. Really looking forward to our agenda today. So let's go ahead and get started. We've got a lot of stuff to talk through. So, we like to look at the numbers. So we like to say we've got 295 open source developers. It's great to see growth even during the holiday season, even when people are gone and things quiet down. We're still seeing new developers joining. We're seeing 151 new stars for GitHub. People coming into Slack. We're almost close to 8,000 community members in our Slack community. If you haven't joined our Slack community yet, we highly recommend you to do so. It's a great place to go and talk to other people in the community, talk to engineers, ask questions, get help getting open metadata up and running, either locally or in a production environment. There's a lot of people there. There's regular office hours that are held as well to help you with any questions that you may have, and to share learnings with the community. So we're on Twitter, we're on Meetup as well, which is this meeting that we're having here today. It's a great way to share and trade learnings for how you've used open metadata, or if you're still early in your open metadata journey, ask those who are further along so you can learn from them. There's a lot of activity in our Slack channel, people asking questions, people providing answers. And you've been down the road, if you've asked the question before, if you're a veteran to open metadata, always feel free to share your learnings and pass it forward to others as well. Some more numbers. So we can definitely see how things quieted down in the holidays, but things are definitely picking up with the new year. There's been, a big jump in PRs within the start of the new year, over 170 PRs in the last 4 weeks, as well as a lot of support questions and posts. So, we take support for the community very seriously. So come into Slack, ask your questions, and we'll do our best to help you as a community to make sure you're successful with open metadata. More numbers here, lots of questions, high levels of resolution, bugs and feature requests, and as well as activity within Slack as well. So definitely really great to see the activity and engagement from the community. And it extends to more than just support questions and Slack posts. We're really appreciative to how people are adding to the open source project as well. So here are some thanks to people from, again, you see names from all around the world, from a lot of different places, contributing back to open metadata, putting in commits and PRs to help expand the project, add new support, provide bug fixes. Again, open source works because of the community. We have more eyes looking at the software, contributing back, helping to provide fixes, and helping to drive and solve problems for how we solve data for modern data teams. So with that, let's actually get into the heart of our content today. I'm very excited to welcome the Carrefour Brazil team. We have teams from data platform and engineering, data governance and quality, all here to share how they're using OpenMetadata as part of their deployments. With that, let me actually pass the baton over to the Carrefour Brazil team to share their story.
Thank you, James.
Hi, everyone. Introducing myself, my name is Rony, and I'm the Data Platform Manager at Carrefour Brasil. And today, we will share a bit about our open metadata experience over the past year. That is just our quick agenda and the covered topics today. To do that, it's a small part of our dream team that will speak to you today, and I will briefly introduce about your company, teams, and the environment, and after, the team will take the lead. So, may you know, Carrefour is a global French company retail that is started its operation in Brazil in 1975, and now we are the largest grocery retail in Brazil. So speaking of numbers, we are a 130,000 employees company with more 1180 stores and of course e-commerce, serving more than 60 millions of people every month. And at bottom, we have our brands, Atacadão, which is a cash care brand, and Carrefour. It has hypermarket, supermarket, and another retail formats. And Sans Club, it's a membership-based retail founded by Walmart, but since 2021 is managed by Carrefour here in Brazil. So, as impressive a retail company, we are generating a large amount of data. And now you can check some big numbers about our analytical data environment that we are using to handle that. At first, we are based on Google Cloud Platform. So you have more than 40 GCP data projects and over than 3,000 tables in BigQuery. And daily, we are running more than 500 data pipelines. Of course, there's a lot of number to check after, but it's important to say that to navigate this complex analytical data environment, you have a powerhouse team, and I will speak about that right now. Our team is organized in a CDO structure, and the person who is our CDO is Arthur Silveira. And it's important to say that we were totally sponsored by our CDO and his directors, like Vinícius Coelho and Thomas Takahashi. And each of these data teams has collaborated to this, and it was essential to our success of implementation. But I will focus on data platform, which is the team who I'm part of. Talking about data platform, the team was founded, it has been 1 year, and is the team that I'm privileged to lead. This team is organized in 4 capabilities. It was designed to support other data teams implementing and defining some data core issues, while the data teams is struggling to serve other business areas or even bringing more insights. And of course, there more information about that, and you can check it later. But why I'm talking about this structure in an open metadata presentation? The reason that I'm bringing this up is just to recommend that implementation of open metadata should begin with a data governance team, of course, backed by a strong executive sponsorship, if it's possible. It will increase your success of a chance of a success implementation. Because in my opinion, open metadata is not just about a technical solution. It addresses and solves so many complex data issues faced by companies, and this project must to be the focus and attention that this type of challenge deserves. And the last but not least, I need to thank our other data teams that was engaged on that, like your data community team and the GRE team. And special thanks to Larissa and Jennifer, who were part of your team during this project implementation, and were essential in making it possible for us to present this case today. So now I will pass the floor to Brenda, who will talk about our project, as well as introduce our other speakers, who will demonstrate how open metadata is helping us overcome our challenge. So it's up to you, Brenda.
Thank you, Ronnie, and hello, everyone. I'm Brenda. I'm the coordinator of data governance and quality team here in Carrefour. Addressing what Ronnie was talking about, why are we here today to talk to you about open metadata and how did we come to adopt open metadata here in our team? Our history starts at the end of the year 2023. Our data platform team conducted many workshops to identify the challenges faced by our data teams. After we analyzed these issues, we found out that a data catalog could address many of these challenges. 4 of the 5 pain points could be solved through a data governance tool, which is, of course, open metadata. Here we can see some pain points that we mentioned during this workshop, including the lack of data lineage, data owners, data catalog, shared knowledge documentation, and a data dictionary. Here we can see in red the pain points that we found out that was caused by a lack of a data governance program and also a tool. Now that you understand our motivation for implementing open metadata, I will share a little about our journey in 2024. In January, we completed our proof of concept and named our tool as C4Data, as you can see the logo above. So every time I talk about C4Data, it's also open metadata. We ended the project definition with the sponsorship of our CDO and all data leadership. We began the project by defining data roles, identifying the owners, and the domains that exist here in Carrefour, Brazil. In April, we deployed C4Data to production using GCP environment with Kubernetes GKE. This deployment was carried out with the collaboration of DRE team, which is part of data platform team. Thank you guys. We organized our first workshop with the first data team, the data engineering team. By July, we hosted an event that we called Datathon. Datathon was a type of hackathon where all data teams were given goals for cataloging tables and dashboards. We launched C4Data in waves and created data cataloging seals, which Vladia will tell you later about it. We held an increasing number of workshops for data and business teams. In October, we launched our observability program, which included adding new data quality tests. We created some automation so that quality tests could generate JIRA requests, and we also used Open Metadata API to send emails. By December, we made an additional progress in our data development by creating customized data quality tests. We reapplied our data assessment questionnaire to revisit the work that we made in the end of 2023, where we collected the pain points I said before. We also showcased our open metadata implementation in Carrefour Global Meeting, where we found people from Poland, France, Argentina, Brazil, and many other countries. Additionally, we continue creating new automations through Open Metadata API. For 2025, we already have many ongoing projects, which I'll tell you later in the end. We brought here the features we use the most, such as data owners and data domain session. Today, our top feature is table and dashboard cataloging. We also make use of data lineage visualization. And in data quality section, as I mentioned earlier, we have been focusing on developing data quality tests and customized tests. Our glossary of terms includes over 300 terms, making it a relevant data dictionary with concepts and many business rules. Additionally, we use lots of kinds of tags to enhance our data. Now, talking about tags, Vladia will share a bit about our data cataloging seals, which are a way we implemented these tags to help us in monitoring metadata cataloging.
Thanks, Brian. Hi, everyone. I'm Vladia, and I am a data governance specialist. Well, let's talk about seals and some new strategies that we've implemented to improve our cataloging process. So, what mechanisms do we use to improve the quality of our cataloging? We have adopted catalog quality seals award for this purpose. So, we created the red, bronze, silver, and gold seals. We saw that seals will now be part of OpenMetadata, so we got ahead it, you know. um, so we have divided several criteria to achieve its seal. The criteria range from no information or basic information from the same metadata to information that supports object monitoring, such as provide support for data quality. For example, knowing the updates freaks of table. We had also automated the seals during table and dashboard ingestion. Therefore, every ingested table and dashboard has each criteria checked and receives specific seals. Typically, the table comes with cataloging that was previously done in GCP, at least the description of tables and columns. In the context of seals, what strategy do you follow to improve the quality of our data cataloging? First, we took some actions to improve the culture and learn us about the importance of having quality in data cataloging. We conducted several workshops and put a lot of effort into communication. But like Brenda explained before, our first milestone for engagement cataloging was the datathon. The entire data area and some key business people participated. At the datathon, winners were determined solely based on the numbers of catalog data assets. So in the first phase, we wanted to strict with the seal criteria, but we were already planted the seed. After that, we moved on to the year-end goal. Finally, this time, we emphasize the importance of the seals, establish a target percentage of gold and silver to be achieved in catalog objects and zero red alerts. The support for tracking the numbers related to the seals applied to the tables was provided by a report that we automated to monitor the numbers. Here, as you can see, we have an image that shows how much we've improved in gold. We retrieved the data from the OpenMetadata base in MySQL. Now, Kelly will continue by explaining in more detail how we have advanced data quality in OpenMetadata.
Hi everyone, I am Kelly and I have been working as a quality analyst at Carrefour for almost 4 years. The tags, test case, and the column profile for open metadata were essential for developing these 5 quality dimensions: update, unique, nullity, consistency, and accuracy. And the other tags are tables from BigQuery GCP. Now I will give a brief explain for each quality dimension. First, for the update dimension, you create a tag for the frequency of table updates, such as daily, weekly, monthly, quarterly, semi-annual, and annual. So, all tables that are cataloged and open metadata with this tag are covered by this dimension. We don't need to use the ingestion profile because we build a separate system that checks the information schema table storage for each project, and then don't use the open metadata database to retrieve the tag information and the verified database status in relation to update dimension. For the nullity dimension, we use the column profile feature and configure the open metadata retrieve 100% to the profile sample. This way, you can check the column contents, identify this with 100 nullities, mean this column have never been used. For the unique dimension, we create a tag called primary key. Any column with this tag means the data must be unique. This way, use the profile data time series table for Open Metadata database to check which column do not have 100 uniques. Additionally, for table that don't have a primary key, you implement a custom SQL test to detect any full duplicate rows. For the consistency and the accuracy dimension, you develop a custom test case to validate business and the governance rules. Today, you have almost 6 test cases to verify the potential incidents. Which college mention following the same cycle? First, you configure the tags and the tests. When an incident occurs, a report is automatically created in the Jira system. This incident report is returned in the comment format of the Open Metadata. We are using the Open Metadata API to perform this action. Additionally, the respective owners receive an email notification about this incident created. So, with this application, quality mention using the tag, column profile, and the test cases for open metadata, we enhance the data observability and quickly mobilize the support team before stakeholders ever notice the data issues. This proactive approach was key to solve the problem, efficiently building trust in the process. Now you bring the conclude this presentation.
Thank you, Kelly. Well, everyone, to wrap up, we brought these numbers to highlight our process during the year. We come from 0 to over 500 users in C4 data. We catalog thousands and thousands of columns, many tables and dashboards. We built a strong glossary of terms and established a well-defined data domains and data owners. We achieved these numbers with a great support from Carrefour Brasil data community and the teams that dedicated themselves throughout this year. For the year that has just begun, we are focusing on data lifecycle governance, great expectations integration to expand our data quality tests, and implementing more and more automations. We want to make our data catalog even bigger by cataloging tags, ML models, and APIs. Our mission is to further democratize data in here in Carrefour Brazil. That's it, everyone. I sincerely thank you all for attention and time. I would also like to thank everyone in the community for giving us this space and for always providing us support on Slack. If anyone would like to connect with us, we are also part of the community on Slack, and our LinkedIn is here below. Thank you.
Very nice. Thank you so much for that presentation.
Thank
I
you.
really liked that graph that showed. I could see the red alert and bronze lines going down, and the gold line going up. So I was like, oh,
Yeah.
you're tracking the data, and you're actually putting in the effort to actually improve the quality of your data as part of that. So really appreciative for sharing your story. And you've definitely done it, and you've really done it at scale with all those metrics that you shared. We've had some questions come in on Slack or on chat. Again, please feel free to put in questions in chat. We do have quite a bit of content to run through, so I do want to pass the baton over to Mayor. And at the end of our presentation, we'll open up the floor for open Q&A for everyone involved. But just so then we can give Mayor to go in through. I know he's got a lot of content and demos present ready here as well. So feel free to put things in chat. But Mayor, please tell us more about Lineage.
Sure. Uh, Thanks, James. Uh, so my name is Mayur. I am software engineer at Collate, and today I'll be discussing about the lineage feature in depth, available in OpenMetadata. We will be focusing main on these three topics, that is automated lineage extraction, how we capture the lineage across different types of connectors in open metadata. Then we'll take a look at how you can make use of lineage to do the end-to-end analysis. And finally, we'll be taking a look at all the features available on the open metadata UI, which can help you consume the lineage in an efficient way. But before jumping onto that, let us first understand what is lineage. So lineage is end-to-end flow of data, that is right from the absolute source to the absolute destination and everything in between. Uh, People often confuse data lineage with ER diagrams. But ER diagram just shows you how your tables are modeled within a database. Lineage gives you a bigger picture than that. Lineage uh, represents the flow of data across different tables, across databases, different types of connectors, and different services. With the help of Lineage, you can experience improved governance within your organization. You can implement better data practices for better efficient, for taking efficient decisions. Lineage also helps in root cause analysis. We will take a look at this when we discuss about the end-to-end lineage in OpenMetadata. And finally, Lineage gives you a better understanding of your data flows across different data infrastructures. Uh, so let's see how automated Lineage works in OpenMetadata. So every operation in OpenMetadata happens via API, because OpenMetadata is built on top of specifications and APIs. So similarly, to create lineage in OpenMetadata, we use lineage APIs. These lineage APIs are built on top of lineage specifications. So this lineage specification is designed in this way that it can connect any two assets available within OpenMetadata and form the lineage. To give you one example, let's say I have a API endpoint, create user, that flows from that, it goes to a Kafka topic, and from that it goes to let's say a BigQuery table, and finally to a dashboard. So this way you can connect different types of services via the lineage. Since open metadata supports vast variety of data infrastructures, lineage specification and lineage API makes it very easier to create the lineage. Now, how do we automate the lineage extraction? So there are mainly three ways how we capture the automated lineage. First one is SQL query parsing. We have been developing a custom SQL query parser from past 3.5 years. Uh, this SQL query parser has been built on top of SQL lineage. Uh, we have got a lot of feedback from the community, with which we are continuously improving our query parser, and are also contributing to other open source projects like SQL Fluff and SQL Lineage, so that entire community can take advantage of this improvement. And another way of capturing lineage is intelligent passing of dashboard service queries, or the API responses that we get from the dashboard, which gives us information about the data warehouses, databases, from which the dashboards or the pipelines extract the information from. And the final way is integrating right into the ETL tools like Airflow, dbt, Spark. We have been developing custom tools to integrate with this platform, so that your lineage experience gets better, and we are able to capture the end-to-end lineage. So let us start with the exploring the database lineage extraction. So there are three ways we extract lineage from a database. First one is view lineage. So while you do metadata ingestion of any particular database in open metadata, we also capture the schema definitions. These schema definitions are then passed to our custom SQL parser, and from that we compute the lineage for views. The next one is stored procedure. We recently introduced stored procedures as well, and we are also capturing the stored procedure lineage, similar to how we pass the view definition. We pass all the queries executed by a stored procedure and prepare a lineage between that. And finally, we also pass lineage via query analysis. Uh, Many databases maintains a history of queries executed on top of those databases. We extract that query history, perform the query analysis, and prepare lineage on top of that. So I have set up a Snowflake instance where I have executed the lineage and the metadata workflow. Let's quickly take a look at the metadata workflow and what are the different configuration available. So there are filters available here. So you can filter what types of what tables, what schemas you want to perform lineage on. And then there is query log duration. This query log duration helps us understand, helps you configure how many days of lineage you want to extract from the query history table, which will be used for parsing and using for lineage analysis. Then there is result limit, which shows how many queries for each day you want to extract to perform the lineage analysis. And then there are advanced filters available so that you can restrict your query set to perform analysis. For example, let's say I do not want to process lineage on queries which are generated from Metabase, for example. So I can just paste a SQL condition like this over here, and it will ignore all the queries which are generated from Metabase. And again, I we have recently implemented the multi-threading as well, which improves the performance of the lineage workflow and makes it run even faster. And this all information is extracted, as I mentioned, from a query history table. Now, suppose there is a database or a database connector which does not support maintaining the query history. In that case, you can prepare your own custom solution where you can maintain all the list of all the queries executed in a CSV file, and you can pass that CSV file as well in this configuration, and that CSV file will be used as the source for fetching the queries and performing the analysis. So it expands your scope of all the number of databases that we support for lineage. Now let's go to some tables and see the lineage in action. And let's start with a view. So I have a test view. We can see that the table type for this is view, and I also have a view definition available over here. We can see that this view was generated from test underscore table. And when I go to the lineage tab, I can see that a lineage getting created between the test table and the test view. And when I click on the edge, it gives me more information about this lineage. By default, it will give you source and target, that is the test table and test view. There is an option that you can also provide information about this lineage in detail. You can add a custom description. It also shows the transformation, or in this case, the view DDL, which was which resulted in this lineage, and finally the source of lineage, that is the view lineage. Now let's take a look at stored procedure lineage. So in this schema, I have two stored procedure. And when I click on the lineage test, I can see the DDL of the stored procedure. And we can see it is a insert statement. It is inserting into test table 2 and selecting from table test. So, and when I come to the lineage tab, I will again see the lineage between the test and the test table 2 created. And also the query which is associated. So again, when we extract this query from the query history table, we'll pass it to our SQL parser, which will indicate that the test table is the source of this lineage, and the target table is test underscore 2 table. And finally, we will make use of the lineage API and create lineage between these two tables in our open metadata ingestion package using the Python SDK. And the final form of lineage is through the query analysis of the query history table. So for example, this is a CTS table. And when I come to the lineage tab, I can see that this table was created this way, that create table CTS as select star from test underscore Pablo. And while we capture the lineage, it is not only the table level lineage, but we also capture column level lineage as well. So when I click on layers and I click on columns, I can see that IND column is connected to the IND column of test CTS, and similarly, name is connected to name. So that was about the database lineage. There is another type which we support for databases, that is DBT, but we'll talk about that in the later section. Then we perform automated lineage extraction from the dashboards. So from the dashboards, we make use of either queries or the APIs that are available for each dashboard. We pass this information and try to interpret the lineage. So again, here I have a Tableau instance ingested, and in the ingestion section, I can see that I have performed a metadata ingestion for this one. And when I click on the edit button, I can see that I am passing DB service name as Redshift fraud, which I am aware that is the data source for the lineage. Now, Tableau itself will not give us a fully qualified name or a unique identifier of a table available in open metadata. That is why, to restrict the scope of search, you can specify whatever the data source is available for as the source of lineage for this one, and we can specify the service name. And while 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 doing this ingestion, the Tableau captures dashboards and data models. Data models are the one containing all the information about the different columns available. And when I come to the lineage section, I will see that this customer's data model is connected to customers table available in Redshift, which is the data source and the table. And finally, this data model was used for preparing a customer's report. And the column level lineage is not only restricted to the table to table lineage, but it is also supported from table to the data model lineage. So when I click on layers, click on the columns option, I can see all the column level lineage here as well. And the next type is pipeline lineage extraction. So similar to dashboard, we make use of APIs provided by these pipelines, or we integrate directly into the pipelines to extract the lineage information. So for a demo, I have my Airflow setup, and within Airflow, I have a sample lineage as a DAG. And we have built a custom plugin for Airflow, using which you can specify what are the source and the destination for a task available in the DAG. Now here you can specify the inlets and outlets, and it contains a fully qualified name of the data asset available within open metadata. Those who are new to open metadata, a fully qualified name is a unique identifier to identify an asset in open metadata. So when I will ingest this Airflow instance in my open metadata, I will see the lineage getting created. and the same information that we have specified within this task gets reflected here as well. Now, this was an example of Airflow, but we also support the pipeline ingestion via APIs. For example, we'll in the later part we'll see how we extract lineage from 510. Uh, and finally, the Spark lineage. So consider you have Spark jobs running on your data infrastructure. To capture this information, we have developed a custom Spark agent which you can use to capture the Spark events and then later interpret those events to create lineage in OpenMetadata. To demonstrate this, I have a Databricks instance setup. Now, Databricks, we do support automated lineage extraction with Databricks, but there are some limitations to that. So to perform the automated lineage extraction, you have to either use a SQL warehouse, which maintains the log of all the queries which is required for lineage perform, uh, or you can use the Unity catalog, which maintains the lineage itself. But consider this scenario where I am using a compute instance and and I'm using legacy Databricks workflows. So here you can install the OpenMetadata Spark agent jar, and whenever you are executing any query which qualifies for lineage using the same compute instance, that that lineage will get captured by OpenMetadata automatically. So, for example, here you can see that we are inserting into table 4 and selecting from table 1 and table 2. So the same lineage gets captured in open metadata, and we can also see a Spark pipeline getting created, and the source, and it also captures the transformation query and the source of lineage as a Spark lineage. So these are the various types of lineage extraction, automated lineage extraction possible with open metadata. Now let's see how you can capture end-to-end lineage for your data architecture. To do this, I have prepared a small example. So consider I have an online application, uh, and let's say it is an e-commerce application. I'm using a Postgres as an online database for this application, which stores my live data. And then there is a 510 pipeline which extracts the data from Postgres and moves it to Redshift data warehouse. Within the data warehouse, I have three categories of table. The first one is raw tables, where the data from Postgres gets directly dumped onto these tables. And then I make use of dbt to perform transformation and aggregation. And dbt will be responsible for creating some staging table and final aggregated table that will be used at the end and get consumed by Tableau reports. So let's see how this lineage can get captured in open metadata. So I have this Redshift instance ingested, and I'll quickly go through all the ingestions available. So we have executed metadata lineage, dbt lineage, dbt workflow, lineage workflow, profiler workflow, and the usage workflow. Now, since we have not talked about dbt, let's just quickly go into that. So we can extract various types of metadata from dbt. That is, we can extract uh, documentation, ownership information, tags, and descriptions. Uh, but apart from that, we can also capture lineage using dbt. And our you can either use manifest and catalog file for the dbt ingestion. You can either store it locally, you can store it on a and make it available as a HTTP endpoint, or you can store it in any of the object storage, or you can directly make use of dbt cloud as well. So once you have provided all the required credentials, in this case, I have to provide a manifest file and a catalog file. We will pass this manifest file and catalog file to extract the lineage information. So let's go to databases. When I click on databases, dbt Jaffel, and customers database is my final aggregated table. So I can already see that there are some staging tables and a aggregated table that is customer, which is connected to the customer's data model, which we previously saw in an example of dashboard lineage. But let's say I want to see the entire lineage. So I can just click on the settings. Instead of upstream and downstream depth being 1, I can just set it to 10 and click on OK, and I can see the entire lineage in a single view. So in this example, in the example that I just showed, we saw that we had some Postgres tables. So in this scenario, we have 3 Postgres table: orders, payments, and customers, which went into raw tables of Redshift via a 5-to-10 pipeline. Now, these raw tables then get transformed into a staging tables via dbt. So when I click on this edge, you can see the dbt transformation query and also the source of lineage as dbt lineage. And there are also icons here specified so that you can identify what are the nodes, what are the dbt models available in this lineage. And finally, this not only shows me a table level lineage similar to the other examples, it also gives me a column level view of the lineage. Now, this lineage information can get overwhelming if you have many number of nodes. Yeah, so for example, so I have here, let's say I'm interested in knowing what is the lineage for a particular table. So I can just click here, search for the payments table to see what is the lineage associated with payments table. So when I click on it, it will highlight the payments table itself, and it will also highlight the entire lineage of payments table, right from where it starts to where it ends. This search feature is not only restricted to table, but it also allows you to search the columns. For example, let's say I want to view the payment method lineage. So when I click on this or search for it, it will highlight the column level lineage as well. Okay. Now, let's assume you are a data scientist. One day you were taking a look at the customer's report and you found out that this report is broken. Uh, Now, if you didn't had this lineage view to identify what is the root cause of this breakage, you will have to go through various systems. That is, you'll have to validate Tableau, Redshift, dbt, and then finally 5-10 pipeline and Postgres to identify where is the actual problem to get it resolved. Now, within layers, we have this little tab for observability. When you click on that, it will show you all the test cases that are performed against each tables. For example, for customers table, we had around 8 tests, and we can see 5 of them passed and 3 of them failed. Now, to get more information about this test failures, I can just click on the observability tab and it will show me what are the exact tests that failed. So we can see there is a completeness test which got failed and a uniqueness test which failed as well. And interestingly, you can also see the from where it failed, it shows the highlighted lineage in red color, and the other lineage which got successful in a regular blue color. Uh, Finally, apart from filtering on basis of columns and tables, you can also do some advanced filtration on the basis of domains, owners, tags, and columns. Let's say I want to view all the data assets available within this lineage which are associated to sales domain. So I can just click on this domains filter, click on sales, and click on update, and it will show me the all the assets that are under the sales domain. So for example, the customer table is in sales domain, and so are all the assets that are displayed here. You can do similar filtration on basis of owners, tags, and columns. And it is also possible to filter on basis of tiers, services, and service type. Uh, and we also have this interesting feature for exporting the lineage. So let's say when I click on export button, it allows me to export and save the CSV file. When I open this CSV file, you can see all the information available within this graph has been presented in this CSV as well. This CSV file can be useful for impact analysis, manual validation of lineage. Uh, it contains all the information about domain, source tables, target table, or pipelines available within this lineage. Also, the column level lineage available. Uh, so this was about the end-to-end lineage. You can see it captures the lineage right from the source that was Postgres to the end that was my Tableau uh, database dashboard. Now, there are other catalogs, like one that came into comments as well, GCP Dataplex, and there are Unity catalog, Glue catalog. This also provide the support for lineage, but it has a restricted view. For example, let's say I have my Unity catalog available here, and when I go to the lineage tab, I can only see the lineage available within this environment, that is Databricks. Similar to that, AWS Glue will give you a lineage of all the assets that are available within the AWS ecosystem. But since OpenMetadata supports around 80 plus connectors, and this lineage can be captured automatically, OpenMetadata is in this unique position to capture the lineage right from the source to the destination, not worrying about if the connector is available within the environment that you're using. Uh, and finally, let's take a look at one of the most interesting feature on top of lineage, that is lineage propagation. So suppose I have this orders table. The data flows from orders to raw orders to STG orders, and the columns and the information available uh, are more or less the same. That is, the ID flows from one table to another. So the documentation related to this ID will also remain the same. Now, let's say I documented my source table, and I want to propagate the same documentation to all the upstream nodes. I can just go to the governance, go to automations. Uh, okay, there is something wrong. Maybe I got logged out. Let me just quickly log in again. Yes. So here you can see I have a lineage automation created. And when I go to in details, I can see that I've created this automation where I'm targeting all the tables available within my Collate instance. And I have applied a filter that I want to perform this operation on Snowflake service type. And within the actions I've selected lineage propagation, and I have selected all these options available. That is, you can propagate description, glossary terms, owners, parent information, tags, tier information, and the same information at the column level as well. So it takes some time to run this automation, but for the sake of this demo, I have already executed it, and I can show you in my Snowflake instance. So in the beginning, we saw this view getting created from the test table. So when I go to this test table, you can see I have some description set at the column level as well. No tags as such, uh, but since we have the description, the same description will get propagated to all the downstream nodes. So for example, when I go to test view, I can see the same description is available at the table level and also at the column level. If I had attached any tags or glossary terms, that would have got propagated as well. So that is how lineage automation can save efforts for repeated documentation uh, and makes your life easier. So far we discussed about uh, different types of lineage capture possible in open metadata, how API and UI supports the editing and updation of lineage. We also saw many filtering available in the UI, which makes it easier for you to consume the lineage. And finally, we also saw the lineage layers, uh, where you can see the data observability tab, the column level lineage, and we also had a look at the root cause analysis via the lineage. Now, these are all the features that are available right now, but let's see what is coming next. So in our roadmap, we have governance as a lineage layer. So similar to the data observability layer, will be introducing a governance layer which can help you with your governance workflow right in the lineage view. And currently, the lineage is available at, let's say, table level, but we plan to introduce the lineage at service level as well, so that in a single screen, you can see the entire lineage of all the tables and assets available within the same service. Then finally, we had a look at the lineage export functionality, but we plan to implement lineage import functionality as well, so that you can perform the bulk addition of or removal uh, right in a single click. We also saw stored procedure lineage, but currently it is limited to stored procedure written in a SQL language. We plan to increase the coverage for SQL, for stored procedure lineage and introduce different languages such as JavaScript as well. And finally, the last feature that we plan, last but not the least, feature that we plan to implement is automated removal of expired edges. We plan to you to configure expiry for different types of lineage, and once that expiry get passes, the lineage will get automatically removed. So that was about a brief summary of what all are the features available and what is in our roadmap. If you have any questions related to this, please let us know.
Hey, thanks so much for that lineage deep dive. We really took the end-to-end and end-to-end for that. So it really is a lot of pieces from all the different data sources, through all the different pipelines, down to the dashboards. We see the simple black line that connects it all together, but there's definitely a lot of pieces that are necessary to bring that all to bear. We're at time, so thank you so much, Mayor, for your deep dive and for all the conversations we've had in chat. We always seem to have more questions than we have time to respond to. I'd encourage you all to come into the Open Metadata Slack channel. You can find all of us there. You can find the Carrefour Brazil team there. You can find the Mayor and the Quality team there, and the rest of the Open Metadata development community there too. Help support the community by storing us on GitHub. You know, your stars help us to create recognition for the Open Metadata project. You can also follow us on Twitter. And if you're interested on getting started with Open Metadata, as an open source project, please feel free to, get it deployed locally on your Docker, get it scaled out into production. We have a sandbox with demo data that you can go and try out on openmetadata.org. So you can try Open Metadata with some demo data. If you're looking for a little bit more help with Open Metadata, Collate offers a free tier of managed Open Metadata. So you can go ahead and try out all the features that you saw today through our feature service and get help from the team if you need to grow and scale that out as well. We're at time, but thank you all so much. It's been a great 2024, and we're super excited for 2025. The roadmap features that Mir's presented is just one small slice just in Lineage. I know there's a lot more in plan across the overall Open Metadata platform for all your different use cases for discovery, observability, quality, governance, and more. With that, I wish you all the best with 2025, and thank you all so much for your time to join our community meeting today. And we look forward to seeing you out on Slack and hopefully at our next community meeting as well. All right, with that, wish you all the best and have a great rest of the year.